Hi everyone, welcome back to another video from my channel. In our last video, we discussed about the variance and standard deviation of any discrete or continuous data. Today, we will be learning about coding in statistics. Coding is a way of simplifying statistical calculations. Each data value is coded to make a new set of data values which are easier to work with. In your exam, you will usually have to code values using a formula like this, where y is equals to x minus a divided by b, where a and b are constants that you have to choose or are given with the question. When data are coded, different statistics change in different ways. If data are coded using the formula y is equals to x minus a divided by b, the mean of the coded data is given by y mean is equals to x mean minus a divided by b. The standard deviation of the coded data is given by standard deviation of y is equals to standard deviation of x divided by b, where standard deviation of x is the standard deviation of the original data, which was x. You usually need to find the mean and standard deviation of the original data given the statistics of the coded data. You can rearrange the formula as mean of x is equals to b multiplied with mean of y plus a, and standard deviation of x is equals to b multiplied with standard deviation of y using these equations. For number 3, the coded mean price of televisions in a shop was worked out. Using the coding y is equals to x minus 65 divided by 200, the mean price was 1.5. Find the true mean price of the televisions. So it's given that the mean of y was 1.5 because this was the coding. So we can say that mean of y is going to be equals to mean of x minus 65 divided by 200. Therefore, mean of y was 1.5. So we just have to solve for the mean of x or x bar here. And solving for x bar, we can say that x bar is going to be equals to 200 multiplied with 1.5 plus 65, and this gives us a value of 365, which is the true mean price of the televisions. For number 5, a study was performed to investigate how long a mobile phone battery lasts if the phone is not used. The grouped frequency table shows the battery life in B hours of a random sample of 100 different mobile phones. So here we have battery life in B hours, their corresponding frequencies. We are given an empty column of midpoint and y is equals to x minus 14 by 2, which we are using a coding to make the values more smaller so that calculations become easier. So we can calculate the midpoint using the formula of midpoint being equals to a plus b divided by 2, where a and b are the endpoints of the class, where a is the smallest class boundary and b is the largest class boundary. So in this case, for the first one is going to be 11 plus 21 divided by 2, and this gives us a value of 16. Then we have 24, 29, 34, and then 40. Now we can apply this formula, y is equals to x minus 14 whole divided by 2. So for the first one is going to be 16 minus 14 divided by 2. 16 minus 14 is 2, divided by 2 is 1, so it's going to be 1. Then we have 5, 7.5, 10, and 13. And now we have completed the table. This is for number A. For number B, we have to calculate an estimate of the mean battery life. So we can extend this table by adding yf here, which is going to be the multiplication or the product of y with its corresponding frequency. For the first one is going to be 1 multiplied with 11. This gives us 11. And then we have 120, which is by multiplying 5 with 24. Then 27 multiplied with 7.5 gives us 202.5. Then we have 260. And finally, we have 156. And this is the completed table for YF. Now we can calculate the summation of FY or YF, which is 7,495, and the summation of F is going to be 100 as it's given here in the question, or you can also simply add all of them to get 100. Now we can calculate the mean of Y, which is going to be summation of YF or FY divided by summation of F, which we already have discussed in our previous videos. So it's going to be 7,495 divided by 100, which is going to be 7.495. Now, if you notice, Y is not the actual variable. For example, this is not the actual battery life. It's rather the mean of Y. So what we have to do is we have to find the mean of X, which is the actual battery life. So now using the formula, Y is equals to X minus 14 divided by 2, we can say that mean of Y is going to be equals to mean of X minus 14 divided by 2. So mean of X is going to be equals to 2 multiplied with mean of Y plus 14. And substituting the value for mean of Y, we get 2 multiplied with 7.495 plus 14, which gives us an approximate value of 28.99 hours, which is roughly 29.0 hours or 29 hours to 3 significant figures. For number C, we have to calculate the standard deviation of the mean battery life. Now, if you remember from our previous video, standard deviation, which was the square root of the variance, is equals to summation of f squared or fx squared divided by summation of f subtracted with summation of fx divided by summation of f whole square. So here, let us first calculate the value of summation of fy squared, which is going to be the frequency multiplied with its corresponding y square values. So for the first one is going to be 11 multiplied with y squared, which is 1 squared. Then we have 24, which is the frequency here, multiplied with its y squared, which is 5. So it's going to be 5 squared plus 27, which is the next frequency, multiplied with its corresponding y value, which is 7.5. But since we're doing y squared, so it's going to be 7.5 squared. Then add with 10 squared, multiplied with 26. Then 13 squared, multiplied with 12, following the format of fy squared. And this gives us a value of 6,757.75. Now we can apply the formula for standard deviation of y, which is going to be this formula. So square root of 6,757.75 divided by the total number of frequency or summation of f, which is going to be 100, minus the mean squared. So the mean was 7.495 if you remember. So this squared, and this gives us a value of approximately 3.38 hours. Now if you remember, the formula for y was x minus 14 whole divided by 2. So we can say that the standard deviation of y is going to be equals to the standard deviation of x divided by 2. Because if you remember, if y is equals to x minus a divided by b, then standard deviation of y is going to be the standard deviation of x whole divided by b. So using the same format, we can write this. And so the standard deviation of x, which is the original variable, is going to be 2 multiplied with 3.38, which was the standard deviation of y. And this gives us an approximate value of 6.76 hours. For the final question in number 9, the daily mean pressure in P hectopascals in ACPRA during August is recorded. The data are coded using C is equals to P by 2 minus 500, and the following summary statistics were obtained. N is equals to 30, mean of C was 10.15, and summary statistics of C is going to be 296.4. We have to calculate the mean and standard deviation of the daily mean pressure, which is P. So first, let us calculate the standard deviation of C. So if you remember from the previous video, standard deviation is going to be the square root of the variance. And if you remember, the variance had different forms. The first form was x minus x whole square and the sum of all of those. Similarly, the one we just recently used, which is summation of x squared divided by n minus summation of x divided by n whole square. And similarly, it also has another form, which is root over sxx divided by n. So we already have the summary statistics here. So the standard deviation of C is going to be root of the variance of C, which is going to be SCC divided by n. So square root of 296.4 divided by 30 gives us an approximate value of 3.143. Now, because C is equals to P by 2 minus 500, we can say that the mean of C has to be equals to the mean of P divided by 2 minus 500. So making P mean or mean of P the subject, we can say that it has to be C mean plus 500 whole multiplied with 2. And this gives us 10.15 plus 500 whole multiplied with 2, which is approximately 1020 hectopascals to 3 significant figures. And because C is equals to P by 2 minus 500, so therefore the standard deviation of C has to be equals to the standard deviation of P divided by 2. So therefore standard deviation of P will be double the standard deviation of C. So this will be 2 multiplied with 3.143, and this gives us a value of approximately 6.286, which is roughly 6.29 hectopascals. And this is our answer. Thank you all for watching. This is the end of chapter 2 of statistics 1. Please make sure to leave a like, comment, share and subscribe if you enjoyed the content. See you guys on the next video. Goodbye.